So meiosis is the process of making cells for sex. We call those cells gametes, sperm and egg. They are haploid. That means they have half the normal amount of DNA. So you have one of each of the pairs. You got 46 chromosomes normally in a human, so you have 23 pairs. You have 23 chromosomes in a gamete. In meiosis, we're going to double the DNA, divide, and divide again. And we're going to double the DNA. So we'll have more DNA. And then we're going to divide. And then we're going to divide again. The double divide, that's meiosis, right? Mitosis is one division, meiosis is two. So double the DNA, divide again. You still double the DNA where? Leah, during the what part of interphase? The S phase. It's G1, S, G2. Those are the three parts. And the S stands for synthesize because you're making the DNA. You're going to want to know that for the test. Hint. The goal is to make a 1N sperm. A lot of times books don't write 1N, they just write N. If you see N, that means there's a single set of chromosomes. If you see 2N, that means there's two sets of chromosomes. What's the H word if we say it's 1N? It's also called haploid. So you take a haploid sperm and a haploid egg and you get a diploid zygote. And that diploid zygote, it will then do mitosis to grow up to be a full-size human. Okay. So a zygote will grow up to be an embryo to an adult. That's all mitosis. But we're going to talk about how we get the haploid cells. So that's meiosis. Now, you saw from the video, females are XX, males are XY in humans, in mammals actually. In most mammals, platypuses are really weird. We'll talk about that. You can ask me outside of class. All right. So each gamete has one. I put that in italics, in caps, in bold, in red. What do you think that means? Yeah, there are. This is important. If you have two sex chromosomes in most people, then you got one from dad and one from mom. That means the egg has one sex chromosome, should be an X. And the sperm has one sex chromosome. It could be an X, or it could be a Y. It's very important. I want you to understand that the sperm only has one sex chromosome. The first division we call meiosis 1. And in it, we go through prophase, metaphase, anaphase, telophase. So you have prophase 1, metaphase 1, anaphase 1, telophase 1. What do you think of the first and second division? Well, Megan's laughing, you know. Phase 2, anaphase 2, telophase 2, exactly right. Exactly right. Now, the second division is exactly like mitosis. Everything we talked about before, it is exactly like mitosis. You might guess that's a test question. Mary, why would you think that might be a test question? Because it's in red. All right. Okay, so that's straightforward enough. This one, in the first division, there are two phases that are different than mitosis. Sheldon, do you remember when we were both pulling on the spindle fibers and we were threatening to rip our classmates in half? All right, rip the chromosome in half. You don't do that in the first division. You do in the second. In the second one, you line up down the middle. In metaphase, you're lined up in the middle, right down the middle. And in anaphase, you tear the chromosome apart. Meiosis has two cell divisions. They're named just like mitosis, prophase, metaphase, anaphase, telophase. The first division, we're going to separate pairs. Nothing gets torn in half. The second division is just like mitosis. Things line up right down the middle of the cell and get ripped apart through the centromere. Centromere, right? In meiosis, we already used, these are some nerd words, just words you have to know. We already used the term homologous before. They're pairs of the same kind. But if you have chromosomes in pairs, you have a copy of one from dad, a copy of one from mom, those are homologous chromosomes. They're the same kind of chromosome. So it's a homologous pair. We call the one from dad, the one from pa, we call it paternal. The one from ma, we call it maternal. It's not hard. Each of these doubled chromosomes is made up of two chromatids, correct? So there were actually, if you had two double chromosomes next to each other, the metaphase one, you you have 4 chromatids. Do we agree? The Latin word for 4 is tetra. So we call a group of 4 chromosomes, we call the 2 double chromosomes lined up next to each other, a tetrad. This is a big deal because these 4 chromatids, which are 2 double chromosomes, each half of that double chromosome, each chromatid, will be the future chromosome in a future sex cell, future gamete. And so you should get 4 gametes out. Does that make sense? Double, divide again. So this would be meiosis 1, and this would be meiosis 2. Metaphase ways for everything line up. So if you look at this, meiosis 1, you have your prophase 1, metaphase 1, anaphase 1, telophase 1. At metaphase 1, you line up in pairs on each side of the metaphase plate. And the reason there's no tug of war and no fight is because this centriole, when it sends its spindle fibers out, they attach to the middle of this chromosome. They don't attach to that one. And when this one sends its spindle fibers out, they attach to this one. And so, whenever the spindle fibers get short, instead of having a tug of war, here's just short. All nice. Nothing has to be torn in half. Good? Second time, we do it exactly like mitosis. So we line up down the middle. We have spindle fibers grow from the centriole to the middle, and they attach to the chromosome. I know they actually attach to the they attach to the centromere, and then they get shorter, and they pull, and they rip the chromosome in half. So half goes that way, half goes that way. The second division, you line up in the middle, just like, what's the N word, Sheldon, I'm looking for? Yes, you line up just like mitosis down the middle. And then you rip the chromosome apart, just like mitosis. You rip it apart at what phase, Grace? Yes, the A and apart, the A and anaphase, they kind of go together. These are 3 things that sexual reproduction, these are 3 reasons why sexual reproduction promotes genetic variation and makes sure the babies are not all the same. This is a big deal. You have tetrads. This is a double chromosome, this is a double chromosome. It's the same type of chromosome though, do we agree? Right? So if they swap pieces, as long as they swap at the same level and you don't have something weird happening, weird things do happen, you can end up with, instead of just having a chromatid that's all mom's DNA, or a chromatid that's all dad's DNA, you could also have a chromatid that's almost all mom's DNA, but on the end of it, it uses dad's genes, dad's versions of those genes instead. Or it could be mostly dad's DNA, mostly dad's genes, but it's got some mom's on it. So it gives you more genetic diversity. Do you remember I said that the whole reason for sex is that it gives you more chance, it jumbles the genes up so that you have more chance of survival because not all the kids are going to be the same. This is one of the methods. There are actually 3 methods that sex promotes genetic diversity. There's a 4th if you count mutations. But we'll talk about that in a bit. Anyway, the paternal and maternal chromosomes can swap parts. This usually happens in prophase 1. I want you to know for the test that prophase 1 and metaphase 1 are where you have the tetrads. You have the 4 of them just floating around during prophase, and then they come to the middle for metaphase, which is actually really short. So prophase 1, metaphase 1, not 2 for either one. That's when you have the tetrad.